Chapter 1. When lakes become deadly. When most people think about lakes, they imagine calm water, places to swim, places to fish, places to relax. Lakes are supposed to be safe, but on this planet, some lakes are anything but. In parts of Africa, there are lakes so extreme that they can kill silently, preserve bodies like stone, or wipe out entire communities overnight. Two of the most dangerous are Lake Natron and Lake Nyos. Lake Natron and Lake Nyos look ordinary from a distance. Still water, open skies, quiet surroundings. Nothing about Lake Natron or Lake Nyos warns you what they are capable of. But beneath the surface, both are deadly in very different ways. Lake Natron is one of the most alkaline lakes on Earth. Its water is loaded with salt and minerals. Its temperature can reach levels close to scalding. Animals that fall into Lake Natron often die quickly. And when they do, the chemicals in Lake Natron preserve their bodies, turning them rigid and pale, almost like stone. Lake Nyos is dangerous for a different reason. Lake Nyos sits on top of volcanic activity. Deep beneath its surface, carbon dioxide slowly builds up, invisible, odorless, silent. Then, without warning, Lake Nyos can release that gas in a massive cloud. When that happens, the gas pushes oxygen out of the air. People and animals suffocate without ever realizing what is happening. In one night, Lake Nyos has proven that an entire village can disappear. Together, Lake Natron and Lake Nyos show how water, the source of life, can become a weapon of nature. They are reminders that danger does not always look dramatic. Sometimes it looks peaceful, sometimes it looks beautiful, sometimes it looks like a quiet lake under the sun. In this video, we're going to explore how Lake Natron and Lake Nyos became so deadly, why they behave the way they do, and what they reveal about Earth's most extreme environments. Because on extreme Earth, even water can turn against you. And some lakes are not meant to be approached. They are meant to be respected. Chapter 2. Lake Natron, the lake that turns animals to stone. In northern Tanzania, near the border with Kenya, there is a lake that looks more like a science experiment than a natural body of water. From the air, Lake Natron appears bright red, pink and white. Its colors shift with the seasons. Sometimes it looks like blood, sometimes like rust, sometimes like salt flats. It is beautiful and it is deadly. Lake Natron is one of the most alkaline lakes on Earth. Its water contains extremely high levels of sodium carbonate and other minerals, the same chemicals once used in ancient Egypt to preserve mummies. In other words, Lake Natron is naturally filled with preserving agents. When animals fall into Lake Natron, they are immediately exposed to water with a pH close to that of ammonia. This level of alkalinity can burn skin, damage eyes, destroy tissue. For birds, bats, and small mammals, contact with Lake Natron is often fatal. They become disoriented, their wings stiffen, their muscles fail, many drown, and when they do, something strange happens. Instead of decomposing normally, their bodies begin to harden. The minerals in Lake Natron coat their skin, salt crystallizes around feathers and fur, water is drawn out of their tissues. Slowly, they dry out, they become stiff, brittle, pale, almost stone-like. This is why animals found near Lake Natron often look like statues, frozen in lifelike positions, perched on rocks, standing upright. As if caught mid-movement, photographs of these animals shocked the world. They looked sculpted, placed deliberately. But nothing about it is artificial, it is chemistry. Nature doing what chemistry allows. Lake Natron also reaches extreme temperatures. In some areas, the water can approach 60 degrees Celsius, hot enough to cause serious burns, hot enough to kill sensitive organisms. Combined with the high alkalinity, this makes Lake Natron one of the harshest aquatic environments on the planet. And yet, life still exists here. Millions of lesser flamingos depend on Lake Natron to survive. They breed on its salty islands, using the hostile water as protection. Predators avoid the lake. Humans avoid it. Most animals stay away, which makes it one of the safest nesting sites in East Africa. The flamingos have adapted to drink the water, filter out toxins, feed on the algae that thrive in these conditions. What kills most creatures sustains them. Lake Natron is both a graveyard and a sanctuary, a place where death and survival exist side by side. For humans, the lake is dangerous. Touching the water for too long can irritate skin. Swimming can cause serious injury. Drinking it is impossible. There are no resorts here, no beaches, no swimming zones, only warning signs and empty land. This lake was never meant for comfort. It was shaped by volcanic activity in the Rift Valley, fed by mineral-rich hot springs, concentrated by intense heat and evaporation. Over time, it became what it is today, a chemical trap, a natural preservation chamber, a reminder that not all water gives life. Some water takes it away, and then, strangely, refuses to let it disappear. Chapter 3. The Science Behind Lake Natron's Deadly Waters. To understand why Lake Natron is so dangerous, you have to look beyond how it looks and focus on what it is made of. Lake Natron is not just a lake filled with water, it is a chemical mixture, a concentrated solution of salt, minerals, and heat that has been building up for thousands of years. Everything about Lake Natron works to make life difficult. First, there is the salt. Rivers and hot springs flow into Lake Natron, carrying dissolved minerals from volcanic rock. Sodium, carbonates, bicarbonates. When that water reaches the lake, it has nowhere to go. There is no outlet to the ocean, no river flowing out, so the water sits. Under intense African sunlight, it slowly evaporates, but the minerals do not evaporate. They stay behind. Day after day, year after year, the lake becomes more concentrated, more salty, more toxic. Then there is the alkalinity. Lake Natron has an extremely high pH level, often between 10 and 12. For comparison, normal drinking water has a pH close to 7. Household ammonia is around 11, so Lake Natron is closer to a cleaning chemical than to natural fresh water. This alkalinity comes from sodium carbonate, sometimes called natron, which gives the lake its name. This chemical dissolves fats and proteins. When it touches living tissue, it damages cells. Eyes burn, skin cracks, gills fail. For fish, amphibians, and most insects, survival is impossible. Their bodies cannot regulate chemicals in such conditions. Then there is the temperature. Lake Natron sits in a volcanic region of the East African Rift Valley. Hot springs feed into the lake. Geothermal heat warms the water. In shallow areas, temperatures can reach nearly 60 degrees Celsius. That is hotter than many hot tubs, hot enough to cause burns, hot enough to speed up chemical reactions inside the water. Heat makes everything more extreme. It increases evaporation, it raises salt levels, it intensifies alkalinity. All three factors, salt, alkalinity, and heat, reinforce each other. When one increases, the others follow. This creates a feedback loop. More heat means more evaporation means more salt means higher alkalinity. The lake becomes harsher over time. For most life forms, this environment is overwhelming. Cells lose water, proteins break down, organs shut down. Animals that accidentally fall into Lake Natron often experience shock. Their muscles weaken, their coordination fails. They cannot escape. And once they die, the same chemistry that killed them begins preserving them. The salts dry their tissues, the alkalinity slows decomposition, the heat accelerates mineral buildup. It is natural mummification, without human involvement, without artificial chemicals, just physics and chemistry working together. What makes Lake Natron especially dangerous is that it doesn't look threatening. There are no waves, no violent currents, no obvious warning signs. On calm days, it looks peaceful, almost inviting, but the science beneath the surface tells a different story. It is a lake designed by geology to resist life, a system built by volcanoes, sunlight, and time, a place where the basic ingredients of nature combine into something lethal. And Lake Natron continues to grow and change. As climate patterns shift and temperatures rise, its chemistry may become even more extreme, which means its deadly reputation may only increase. This is not a lake that will soften with time. It is a lake that becomes stronger, more concentrated, more unforgiving with every passing year. Chapter 4. Life that survives in Lake Natron. At first, it seems impossible that anything could live in Lake Natron. The water is too hot, too salty, too alkaline. It burns skin, destroys tissue, kills most animals within minutes. And yet, life exists here. Not just a little life. Millions of living organisms depend on this lake to survive. The most famous are the flamingos. Every year, huge flocks of lesser flamingos gather at Lake Natron. From the air, they look like a moving pink cloud. Sometimes there are more than 2 million of them at once. This lake is their main breeding ground in East Africa, and they come here for one reason: safety. Most predators cannot survive near Lake Natron. Crocodiles avoid it, large mammals stay away. Humans rarely approach. The water is too harsh, the ground is too unstable, so the flamingos build their nests on small salt islands in the middle of the lake. Mud and salt harden into platforms. Eggs are laid on top. Chicks hatch surrounded by hostile water. To predators, it is unreachable. To flamingos, it is perfect. But how do they survive in such toxic conditions? Their bodies are specially adapted. Flamingos have thick, scaly skin on their legs that resists chemical burns. Their beaks are designed to filter food from salty water. Special glands in their heads remove excess salt from their bodies. They can drink water that would poison most animals. They can stand in temperatures that would injure others. They are built for this place, but flamingos are not alone. Lake Natron is also home to microscopic life, tiny organisms called extremophiles, life forms that thrive in extreme environments. These microorganisms feed on minerals and sunlight. They do not need clean water. They do not need mild temperatures. They are adapted to chemical chaos. Some of these microbes produce red and pink pigments. That is what gives Lake Natron its strange color. The more microorganisms grow, the redder the lake becomes. In peak seasons, it looks like liquid fire. These microbes are the foundation of the entire ecosystem. Flamingos feed on them. Without them, the birds would disappear. So even in one of the harshest environments on Earth, a food chain exists, built on organisms that most life cannot tolerate. This is one of nature's strangest rules. Where conditions are most hostile, competition is lowest. Few species can survive here, so the ones that can dominate. Lake Natron has no fish, no frogs, no large insects, just specialized life forms. Perfectly adapted, every other creature is filtered out. It is natural selection at its most extreme. Only the strongest designs remain, but this balance is fragile. If the lake's chemistry changes too much, if water levels rise or fall, if pollution enters the system, the microorganisms could collapse, and if they disappear, the flamingos disappear too, which would affect ecosystems across Africa. Because these birds migrate thousands of kilometers, they connect environments, they spread nutrients, they influence food chains far beyond this lake. So, Lake Natron is not just a deadly trap, it is also a vital sanctuary, a place where life survives by becoming different, by becoming tougher, by adapting beyond normal limits. Here, nature proves something remarkable. Even in water that kills almost everything, life finds a way, but only on its own terms. Chapter 5. Lake Nyos, the lake that killed without warning. In northwestern Cameroon, surrounded by green hills and quiet villages, there is a lake that looks completely harmless. Still water, clear skies, peaceful surroundings, no storms, no waves, no signs of danger. This is Lake Nyos. And in 1986, it became the site of one of the deadliest natural disasters in modern African history. A disaster that happened without fire, without explosions, without earthquakes, and without warning. Lake Nyos sits inside the crater of an ancient volcano. Deep beneath the lake, volcanic activity still releases carbon dioxide gas from the Earth's interior. Normally, this gas would escape slowly into the atmosphere. But Lake Nyos is deep, very deep, and its water is layered. Warm water stays near the surface. Cold, dense water stays at the bottom. This creates a natural seal. The gas rising from below becomes trapped. It dissolves into the deep water under pressure, like carbon dioxide inside a sealed soda bottle. Year after year, the gas builds up, silently, invisibly, unnoticed. By 1986, Lake Nyos was holding an enormous amount of dissolved carbon dioxide. Then, one night, something disturbed it. Scientists are not completely sure what triggered it. It may have been a landslide, a small earthquake, strong winds, or shifting water temperatures. Whatever it was, it broke the balance. The deep water suddenly rose, and when it did, the pressure dropped. The gas exploded out, like opening a shaken bottle. A massive cloud of carbon dioxide burst from the lake. It rolled across the surface, spilled over the edges, and flowed downhill into nearby villages. Carbon dioxide is heavier than air, so instead of rising, it sank. It filled homes, covered fields, poured into valleys. People did not smell it. They did not see it. They did not hear it. They simply lost consciousness. As the gas pushed oxygen out of the air, everyone who breathed it began to suffocate. In their sleep, within minutes, entire families were found lying in their beds. Livestock collapsed in fields. Birds fell from the sky. Insects died on the ground. By morning, more than 1,700 people were dead. Thousands of animals had perished. Villages were silent. When survivors and rescue workers arrived, they were confused. There were no burns, no wounds, no signs of violence, just bodies, still, peaceful, as if everyone had fallen asleep at the same time. It took scientists weeks to understand what had happened. They discovered that Lake Nyos had released a limnic eruption, a rare event where gas suddenly escapes from deep water. It was one of the first times such a disaster had ever been documented, and it terrified researchers. Because Lake Nyos was not unique, other volcanic lakes around the world had similar conditions, which meant it could happen again. So, a solution was created. Engineers installed special pipes into the lake. These pipes slowly bring deep water to the surface, allowing gas to escape safely, day by day, year by year, releasing pressure, preventing another explosion. Even today, these systems are carefully monitored, because if they fail, the lake could become deadly again. Lake Nyos is forbidden not because of fences or guards, but because it reminds us of something frightening. Nature does not always need storms or earthquakes to kill. Sometimes it only needs silence. A slow build-up, a hidden pressure, one small disturbance, and suddenly an entire community can disappear overnight. No warning, no escape, just air that turns against you. Chapter 6. The silent threat beneath Lake Nyos. Even after the tragedy of 1986, Lake Nyos did not become safe. The deadly gas did not disappear. It is still there, slowly building up, deep beneath the surface. Because the forces that caused the disaster never stopped. Far below Lake Nyos, the Earth is still active. Magma chambers and volcanic rock release carbon dioxide continuously. This gas rises from deep underground, moving through cracks and fractures in the crust. When it reaches the bottom of the lake, it dissolves into the cold water, just like gas dissolves into a sealed bottle of soda. The deeper the water, the higher the pressure, and higher pressure allows more gas to stay trapped. So, at the bottom of Lake Nyos, enormous amounts of carbon dioxide remain dissolved, invisible, odorless, undetectable without instruments, and completely deadly. What makes Lake Nyos especially dangerous is how stable it normally is. Most lakes mix their water layers regularly. Wind stirs them, temperature changes move them, seasons turn them over. But Lake Nyos does not mix easily. Its deep crater walls block strong winds. Its tropical climate keeps surface water warm. So, the lake stays layered. Warm water on top, cold, gas-rich water below. This layering is called stratification, and it acts like a lid, trapping the gas underneath. Year after year, more carbon dioxide dissolves, pressure increases, energy builds, all without any visible sign. To people living nearby, Lake Nyos looks peaceful. Fishing boats float on the surface. Animals drink from the shore. Children play nearby. Nothing suggests danger, but beneath them is a compressed cloud of suffocating gas, waiting. The real threat is how quickly everything can change. If something disturbs the lake, even slightly, the balance can collapse. A landslide, heavy rain, strong winds, earth movement, any of these can force deep water upward. When that water rises, pressure drops, and suddenly, the gas escapes. It forms bubbles, then streams, then an eruption. Within seconds, millions of tons of carbon dioxide can be released. There is no smell, no irritation, no warning. People breathe it in unaware. Their bodies react immediately. Carbon dioxide prevents oxygen from entering the bloodstream. The brain shuts down, muscles fail. Consciousness fades. Victims collapse before they realize anything is wrong. That is what makes this threat so terrifying. There is no chance to run, no chance to fight, no chance to escape. You simply fall. To prevent another disaster, scientists installed degassing pipes in Lake Nyos. These pipes work constantly. They draw deep water upward, release gas slowly, reduce pressure safely. It is like unscrewing a bottle cap, just enough to let air out. Day after day, year after year, but the system must never stop. If maintenance fails, if funding disappears, if equipment breaks, the lake will begin storing gas again, silently, patiently. Lake Nyos is not dangerous because it is violent. It is dangerous because it is quiet, because it hides its threat, because it gives no signal. It shows us that some of the deadliest forces on Earth are not explosive. They are invisible, they wait, they build, and when they finally release, they do it in seconds. Chapter 7. Lake Natron versus Lake Nyos. Two different ways. Lakes kill. At first, Lake Natron and Lake Nyos seem completely different. One is bright red and salty, the other is calm and clear. One sits in a dry volcanic valley, the other lies in green, fertile hills. One looks strange and hostile, the other looks peaceful and harmless. But both are deadly. They just kill in different ways. Lake Natron kills with chemistry. Lake Nyos kills with gas. Lake Natron is dangerous because of what is in its water: salt, sodium carbonate, extreme alkalinity, high temperatures. Everything about Lake Natron attacks living tissue. When animals touch the water, their skin burns. Their eyes are damaged, their muscles weaken, the lake pulls moisture out of their bodies, crystallizes minerals on their skin, preserves them after death. It is slow, relentless, unforgiving. Lake Natron does not need explosions or sudden events. It is always dangerous. Every day, every season, every year. If you enter Lake Natron, the threat is immediate. You feel it, you see it, you experience it. Lake Nyos is the opposite. Its danger is invisible. There is nothing in the water that looks harmful. No strange colors, no burning sensation, no warning signs. Lake Nyos kills with what you cannot see. Carbon dioxide, gas that has no smell, no color, no taste. It builds up deep underground, dissolves into the lake, waits under pressure for years, sometimes decades. Then, in seconds, it escapes. A massive cloud rolls across the land, and suddenly, the air itself becomes lethal. People do not feel pain. They do not panic. They simply collapse. Lake Natron attacks the body directly. Lake Nyos removes the air the body needs to survive. One poisons, the other suffocates. One works slowly, the other works instantly. Lake Natron is predictable. Scientists know it is dangerous. Locals avoid it, animals stay away. Its threat is visible. Red water, white salt flats, dead animals. Lake Nyos is unpredictable. For years, it can appear safe. People live beside it, farm near it, raise families. Then one night, everything changes. No warning, no signal, no escape. Lake Natron represents permanent danger. Lake Nyos represents hidden danger. One shows you its power, the other hides it. But both reveal the same truth. Water is not always life. We are taught that rivers feed us, lakes support ecosystems, rain sustains crops, and most of the time that is true. But in extreme environments, water becomes something else. A weapon, a trap, a system that turns against living things. Lake Natron and Lake Nyos are created by geology, volcanoes, heat, minerals, pressure. They are shaped by forces far older than humans, and they do not care who lives nearby. They do not adjust for safety. They do not offer second chances. They operate by physical laws, and those laws can be fatal. Together, these two lakes show how nature can kill in opposite ways, through slow chemical destruction or through instant invisible suffocation. Both are reminders that danger does not have one form. Sometimes it burns, sometimes it hardens, sometimes it takes the air from your lungs, and sometimes it looks like nothing at all. Chapter 8. Could more deadly lakes exist? When scientists studied Lake Natron and Lake Nyos, they realized something unsettling. These lakes are not unique. They are extreme examples of processes that exist in many places around the world, which means other deadly lakes could exist, and some may already be forming. Across Africa, Asia, and parts of South America, there are dozens of deep volcanic lakes. Many of them sit on top of active underground systems. Many of them trap gases. Many of them collect minerals and heat. Most appear calm, most seem harmless. But scientists know that appearances mean nothing. After the disaster at Lake Nyos, researchers began scanning similar lakes worldwide. They looked for warning signs: deep water layers that never mix, rising gas levels, unusual chemical concentrations, sudden temperature changes. Any of these could indicate danger. Some lakes in Cameroon, Indonesia, and Central America showed worrying patterns. Gas was building, pressure was increasing, stability was weakening. In other words, they were slowly becoming potential Nyos-style disasters. So, monitoring systems were created, sensors were placed in lakes, water samples were taken regularly, gas levels were measured, satellites tracked surface changes. In some places, engineers installed degassing pipes, the same system used at Lake Nyos. These pipes quietly release pressure day by day, preventing explosions, saving lives. Lake Natron is monitored for different reasons. Its chemistry is constantly changing. As temperatures rise and rainfall patterns shift, salt levels can increase, alkalinity can intensify, water levels can drop. All of this makes the lake more extreme. If it becomes too concentrated, even flamingos may no longer survive, and that would affect ecosystems across Africa. So, scientists watch, they track mineral levels, they study algae populations, they observe bird migrations. Because Lake Natron is not just dangerous, it is essential. It supports millions of animals. If it collapses, entire food chains collapse with it. The same is true for many extreme lakes. They are both threats and lifelines, deadly and delicate. One small change can turn balance into disaster. Climate change makes this risk even greater. Higher temperatures increase evaporation. Stronger rains destabilize slopes. Extreme weather disturbs lake layers. All of these increase the chance of sudden releases, of chemical shifts, of gas eruptions, of silent catastrophes. In other words, the conditions that created Lake Natron and Lake Nyos are becoming more common, not rarer, which is why scientists take these lakes so seriously. They are not just studying water, they are studying future risk. They are trying to see disasters before they happen, because once a lake releases its power, it is already too late. No sirens? No countdown, no escape, just nature acting instantly. Monitoring is humanity's only defense. Sensors instead of soldiers, data instead of weapons, prevention instead of rescue. It is a quiet battle, fought underwater, fought with numbers and measurements, but it saves lives. So, yes, more deadly lakes could exist. Some are forming now, some are waiting. Some may already be dangerous without anyone knowing, and the difference between safety and tragedy may be one sensor, one pipe, one warning sign noticed in time. Chapter 9. When water becomes the enemy. Water is supposed to mean life. It grows crops, feeds animals, sustains cities, keeps ecosystems alive. From the beginning of human history, water has been our greatest ally. But Lake Natron and Lake Nyos reveal a different truth. Sometimes, water becomes the enemy. Lake Natron shows how chemistry can turn water into a weapon. Salt, heat, extreme alkalinity. Together, they create a lake that burns, preserves, and destroys. A place where animals turn into stone-like statues, where only the most specialized life can survive, where one wrong step can be fatal. Lake Nyos shows something even more frightening. That water can kill without touching you, without burning, without drowning, without warning. Just by releasing invisible gas into the air, turning oxygen into poison, turning sleep into death in one night. These lakes are dangerous in opposite ways. One attacks the body, the other removes the air the body needs. One is visibly hostile, the other looks peaceful, but both prove the same thing. Nature does not need violence to be deadly. It does not need storms. It does not need earthquakes. It does not need explosions. Sometimes all it needs is balance and time. A slow buildup of minerals, a quiet accumulation of gas, a stable system waiting for one small change. Then everything collapses. Lake Natron and Lake Nyos remind us that danger is not always loud. It does not always announce itself. It can sit quietly for centuries, looking beautiful, looking calm, looking harmless. until it isn't. They also remind us how small we are, our cities, our technology, our confidence. None of it matters when geology and chemistry decide otherwise. These lakes existed before us. They will exist after us. They do not adapt to human life. We must adapt to them, and when we fail to understand them, we pay the price. But there is another lesson here. Humans can learn. After Lake Nyos, scientists acted, they monitored, they installed safety systems, they prevented another disaster. At Lake Natron, researchers protect fragile ecosystems. They study, they observe, they warn. Because knowledge is the only defense against silent danger. These lakes are not monsters. They are systems. They follow rules, and when we understand those rules, we can survive. When we ignore them, we don't. So, when you look at a calm lake, remember this: it is not always safe. It is not always friendly. It is not always life. Sometimes it is nature reminding us who is really in control. If you want to keep exploring the most extreme, hidden, and dangerous places on our planet, subscribe to Extreme Earth. Because on this world, even water can turn against you. And some lessons are written in silence.